so I just want to review this because I know we sort of finished fairly quickly when we did this last week, but so when we want to determine what kind of compound and what proportions two elements will combine in, okay, we use this crisscross method. This is what we do when we have usually a metal and a non-metal combining, because that's what often these simple compounds end up to be, is a metal bonded to a non-metal. Okay? We always write the metal on the left, non-metal on the right. We figure out their oxidation numbers. We write it above them. Okay? Then we ignore the sign and just crisscross them so that the 3 comes down here, the 1 goes over here, and that's the compound that's formed, Na3P. And so what this is telling us is that 3 atoms of sodium will bind with 1 atom of phosphorus. And it should make sense if we think about their oxidation numbers, because phosphorus has 5 electrons in its outer shell. It's trying to fill up that outer shell. It will need 3 electrons. It's missing 3. So if it gets together with 3 of these sodium atoms, okay, the sodium atoms can each share an electron with phosphorus, okay, so that the sodium is sort of getting rid of the extra electron, so its outer shell will be full, and the phosphorus is getting electrons to fill up its outer level, okay, and they're both going to be sort of stable. If we look calcium and sulfur, okay, calcium is +2, sulfur is -2. When they combine, okay, we end up with Ca2S2, and then we can simplify. All right, so that's how we determine these compounds. And you did some practice there. We did these, correct? Okay, all of them? Are there any questions about how to do this? Does everyone understand how to determine the oxidation number? Okay. So that's the key. All right. Now, we talk about those compounds, and these are simple metals and nonmetals combining. Now, obviously, we use the word metal and nonmetal, but they have a technical definition in chemistry. Okay? Metals are the elements that have less than 4 electrons in their outermost shell. The nonmetals are the elements that have more than 4 electrons in the outermost shell. Again, it's the number of electrons in that outer shell that really determines the properties of how these elements interact and lots of their characteristics as well. And that's why metals have certain characteristics, nonmetals have certain characteristics. In metals, those electrons in our shell, they like to lose them. Okay, they have 1 or 2 or 3 electrons in the outer shell. So for them to become stable, they can get rid of those electrons, and then the layer below that is filled. And so they'll be happy, they'll be stable. Versus nonmetals, which have 5, 6, or 7 electrons, they want to gain electrons. They want to gain electrons to fill up that outer shell and get it to 8. Metals have positive oxidation numbers. Again, we think of that as they have extra electrons that they would like to get rid of. Nonmetals have negative oxidation numbers. And then there's some differences in characteristics. Metals are malleable and ductile. Does anyone know what either of those words mean? Malleable? What?
You could kind of change it around.
Sort of.
Because you can't like shape.
You could shape it.
Yeah.
Yeah. Like think of like a blacksmith hammering some iron or whatever. Yeah, that they can be hammered into a certain shape or stretched ductiles into a thin wire, drawn into a thin wire. Non-metals are generally more brittle, and they're going to break under those forces. And because of the differences between the number of electrons and the oxidation numbers, generally we have metals and non-metals combined with each other. Well, there are some metalloids, some things that kind of could have properties of both metals and non-metals. Okay? And many of these, okay, have those sort of in-between number of electrons, 4 in their outermost shell. We have in our periodic table, where would you expect to find metals on the periodic table? See them?
The top right corner, kind of.
Metals? Here?
Non-metals.
That's non-metals there? Sure? Okay. Catherine?
They're in the middle between the non-metals and the elements.
Okay. So, which side of the periodic table are the metals? Left side. Because if you look at the electron configurations of everything in group 1 has how many electrons in outer shell? 1. Group 2? They have 2. And then in here, if you look closely, you'll notice that the number of electrons is variable. Most have 2, some have 1, and so forth, until you get all the way over to group 13. Group 13 all have what? 3 electrons in the outer shell. Group 14, 4, 5, 6, 7, and 8. Okay? So yes, metals are on the left side of the periodic table. Non-metals are on the right. And we sort of have this staircase here that is where the metalloids are. Okay? And that they sort of, many of the things along that staircase act as both a metal and a non-metal. Okay, they can act in either way. Those are called the metalloids. All right. And our last thing really to talk about here in terms of how these chemicals interact with each other, something called radicals. Radicals are a group of atoms that sort of act together as a unit, and they sort of act as a single element, a single atom. Okay, so they act like one atom, and they have their own oxidation numbers. Okay? If you look on the back of your periodic table, hopefully you have it out, we have a list of radicals, their name, their formula, and their valence number, or oxidation number. Okay, so what you see there are all those things, acetate and carbonate, sulfate, ammonium. These are radicals. So ammonium, for example, an H3, it sort of acts as one unit together, and it has a single oxidation number of +1. We generally keep them surrounded in parentheses to indicate that that is a radical. So for example, if I have nickel combining with this, what is this called? PO4. Phosphate, yes. All right, so we follow the exact same steps to determine what compound nickel and phosphate would form. We write the name of the element or the radical. We find the oxidation numbers. What is nickel? What is nickel's oxidation number? Abby? +2. Has 2 electrons in the outer shell. It's +2. How about phosphate? What is phosphate's oxidation number? Michael? Where'd you find that? Yes, it's on the chart on the back. So plus 2, okay? Phosphate is minus 3. Is that what you said, or you say? Yeah, there's phosphate, there's also phosphite, but they are both minus 3. Then we do our crisscross. Ignore the sign. Okay? And the 3 comes down here with the nickel. The 2 goes here outside of the parentheses. So when those two things combine, we get nickel 3, phosphate 2. Here I have 2 radicals combining. What's this one called? Okay?
Ammonium?
Ammonium. What is this one called? Jake?
Carbonate?
Yep. Okay, so we have ammonium and we have carbonate. Write the symbols. Ammonium's plus 1. What's carbonate? What is it? Minus 2. Crisscross them. And we get an H4, 2, CO3.